So hello everyone, my name is Chitranjan Upadhyay and today we are going to build a ML model which is going to predict whether a person is having a healthy heart or not. Now for this project I have taken a data set from Kaggle, and this data set is having all those vitals information which is tracked by your variables like your smartwatches, Fitbands, and on the basis of that whether we can actually predict and tell whether a person is healthy or not. Now these days you might have come across a number of cases where young people are getting cardiac arrest, so this topic is very important in that perspective. So of course for this project we need to have some domain knowledge of medical field as well, something like cholesterol, BP, these things, but in general I believe most of you are aware of those things. This is the age of information, and let's try to build the ML application from that. So in this model I'm going to use simple algorithms just to give you a feel of how you can build a ML model. But you can comment me in the comment box whether you want a more complex project, and I can create an end-to-end project based on your comments. So let's start our project. Let's work over this model and build this prediction model. So I'm going to share my screen, and for this I'm going to use logistic regression algorithm. This is a classification problem where I'm going to classify person as healthy or not. So let me import necessary libraries for that. Import numpy as np, model selection, and then the metrics for evaluating my model performance. Right, so I believe it is done. Let me import my data set. No, it's not diabetes data set, it's heart disease. You just pay attention to this project. Everyone, whether you are not good with ML or not, doesn't matter, you'll get something out of this project for sure. So I'm trying to use very easy code for this. So let me explore my data set. Yes, ages, sex, these cholesterol, these are the different columns, and the important column is that the target one, which is your independent column. I'm going to segregate that column from the rest of the data afterwards. Okay, and then would split my data set. Let's do some sort of the data analysis. What is my data? Okay, what is the shape of this, and likewise whether there are null values or not, what is the data type of different columns, what is the statistical analysis of my data. Just a minute guys. Right, so this all of you can do and go through your data set before actually creating a model to just know your data set in a better way. Okay, now let me just go to my data set and see the target column, the composition, which is very important. How many are 0 or how many are 1? How many would get heart attack, how many would not get heart attack? 1 is to get heart attack. So I should describe here is 1 is having not healthy heart and 0 is healthy heart. 0 would not get heart attack. All right, so 1 represent defective heart, defective heart. 0 represent healthy heart. Yes. Now I should take my data set differently, that is, dependent and independent columns different. So what was dependent column? Target column was y-axis, so I'm just going to take that off from x-axis. So I'm dropping this, and x is equal to 1, so x is being created, y is equal to nothing but df target. So y is also got created, right? You can see y is only having 0 and 1, 0 and 1, whether having healthy or not heart, right? So now the next step is I just need to split my train test data, and which is I'm going to do splitting train test data. Right. Okay. Just a minute, guys. Train test. So I would use 23 or any number over here just to define the set of the data set we are having as train test. So x test dot shape and x train dot shape, and the shape of your data set. Earlier it was 303, I believe. So it's being divided into the train data and test data, 242 and 61. Yes, 303. So earlier I've shown you the data set shape, na? df dot shape 303. Yes. So you can, it's correct. Okay, it's being divided precisely into train and test. Now let's jump to the model. Let's call our model, then we'll fit our model, train our model training. Which model we are going to use, which algorithm we are going to use? Logistic regression. Classification problem it is. So the basic one is logistic regression. So let me just call it a model. Logistic regression. So it's being created. Now let me train it with data. Okay, it's being trained. Now it's being trained. What is the next step? I would predict it. Then I'll compare whether the predicted data from my model is matching with the actual data. What if not, what is the accuracy score, what is the error? Okay, so model is being trained, it's being fitted. Now let's just predict something. Okay, so I'll just write it, prediction model dot predict. So you can call it prediction, or more better, y predict, y predict, y pred, and I'm using capital Y, so just to make it look uniform, just doing this just to make it look uniform, and y test. This is y trade, so I just need to check it with the y test data. Okay, what is the accuracy score? So my metric was accuracy score, which has imported. So let me just call my accuracy score, and that is, let me put it in a variable, like, just a minute. So I believe, guys, you are getting my point. What I'm doing here, so y test and y predicted data, the error between them, the accuracy between them, I have just calculated with this accuracy score function, and which is 85, which is very, okay, very good actually. So 85% is a good work. So our model is working fine, is giving an accuracy score of 85%. Okay, and you can see the test data. Over the test data, I have predicted something, and this is it. Now let's see whether this model is going to predict something over stranger data, over alien data, foreign data. So I'm going to give a data to it in the same format, like all those features, values. I'll put it to my model, and let's see how my model is going to predict, like whether the person is going to get a cardiac arrest or not. So let's see it. Let's jump to my screen again, and let's build a predictive system out of it. So let me take some data. Let me take in the same format, and as in the same, it has to be match, it has to be matching. Okay, 168, just give me a second. Now I'm changing it to numpy array. Numpy array I'm changing it to okay, is being created. Now let's just fit our model with it, and let's see whether our model is going to predict something out of it or not. Great. So prediction is equal to model dot predict Okay, I just need to reshape my data, I believe. Okay, cool. So now it's being done, and I can see what is the prediction. That simply means he is healthy, he is not going to get heart attack. So I can make it more dynamic, not just printing this, in fact printing if prediction equal to 0, print you are healthy. Else consult your doctor. Yes, you're healthy. So this is all in our project in this ML model, where I have created a model program which is able to predict whether a person is healthy or not based on the features of my data. So now the homework for you is just to try this thing with other algorithms and compare their accuracy. Compare which one is better for this sort of data, for this sort of problem, for this sort of classification problem. Exactly, precisely. So now this is all from my side, guys. Just go through it, try it. This is sort of a easy but effective project which would clear all of your sort of ML concepts and fundamentals. And if you want more complex project, if you want an end-to-end project, just let me know in the comment box. Thank you. Take care. Bye bye.